Hello everyone, my name is Jawad. Today I'm going to have a presentation on wildfire evacuation management at wildland-urban interface areas. This is a part of an ongoing research work with my colleague Professor Amy Kim, which has been started since April 2020. In this presentation, I will go through a background, problem identification, research objectives and context, and a summary of the research. According to statistics, approximately 8,000 wildfires occur each year in Canada. Wildfire seasons are beginning earlier and lasting longer. Fires are getting larger, more frequent and intense, impacting Canadian communities. A major problem arises at wildland-urban interface areas, where homes or other vulnerable community structures meet with wildland fuels. While the common protective practice is to evacuate people from the areas at risk, a large percentage of human fatalities and costs are attributed to poor evacuation operations. This is because the evacuation management is a multifaceted and interdependent problem that involves several actors and factors. As we see, the evacuation problem has all sorts of issues with respect to signals and orders and information dissemination and issues of potentially controlling, guiding, and giving directions to evacuees. These issues, as we can see, are the problems where the autonomous systems can be utilized to come up with an improved evacuation operation. To come up with a solution to improve the evacuation operations with the possibility of utilizing autonomous systems for disaster management, in this study we are aiming to develop a solution to optimize the issuance of evacuation orders, leverage the potentials of local neighbor groups for improved evacuation outcome, and reduce the overloading of roads and uncertainties regarding the evacuation. Evacuation management in case of wildfire has many challenges. For example, wildfire has a rapidly changing nature which asks for safe, quick, and more efficient evacuation plan. There are also other factors that influence the effectiveness of evacuation plan. For example, timely and clear evacuation orders, and also evacuees' compliance to the evacuation orders. To better understand the problem, consider this hypothetical network represent a part of a wildland-urban interface area. Somewhere over the network, a wildfire occurs. As wildfire spreads over the network, individuals are informed or they recognize the danger. Now they face different challenges, such as whether they should evacuate, what time they should evacuate, which destination they need to go. Depending on the situation, we would have different options, but each option would have different level of comfort or danger. Our methodology to address the problem is to utilize mathematical optimization models subject to operational restrictions, such as departure and routing decision, lead time to evacuate, and achieving highest compliance. The model outputs critical decisions such as where from we need to assign the evacuation, at which time, using which path, to which destinations, and when need the evacuees to arrive to the destinations. To wrap up the presentation, in this ongoing research, we are looking to enhance the evacuation operations using progressive decision-making aids such as optimization methods to improve evacuation operations and also plan a time-phase fire response evacuation plan. We also explore the potentials of autonomous systems in providing clear orders and timely guidance for evacuations and evacuees, and also leveraging the benefits of local neighbors and communities to enhance the evacuation outcome. The output of this research will be an integrated decision-making and an advisory tool for evacuation management and dissemination of evacuation orders. I would like to thank ESA Grants for supporting this research. Thank you for listening to this presentation, and let me know if you have any question.